guys, and welcome to another video. In today's video we are going to solve some exercises regarding about logarithms. So the first exercise is to asks us to find the value of this logarithm. Okay, so this is taken from I think from an exam, an American exam, and we have to find the value of this number, of this logarithm. So here I think we have first of all to find the value of this logarithm here. So the value of log of 81, and the basis here is 3. This one is 4 because we have that 3 raised to the power of 4 is 81. So this is the first value. So this exponent is 4. And then we have to compute this logarithm. Well, this logarithm is basically the opposite of this one. So if this logarithm is 4, we have that the logarithm of 3 and the basis here is 81 is 1/4, because we have that 81 to 1/4 is 3. Okay, and now we can put these values in this logarithm. So we get log, the basis is 2, and then we have as we said 1/3 raised to the power of 4. But since here the basis is 2, it is convenient to change here this number. So we can write 1/4 as 2 raised to the power of -2, and then we have this 4, so we have another exponent here. So that means that here we can resort to the rules of exponentials, and then so because of this we get 2 raised to the power of -8, because here we have to multiply -2 and 4, so we get 2 raised to the power of -8. So the final result is -8. Okay, so the second exercise is an equation. We have 3/2 plus log base 3 of the 4th root of x equal to log, here the base is x, of 9x. Okay, so the first thing to do is to well, first of all notice that x has to be positive, so x has to be greater than 0, because x is here under this root so we can write our equation here using this relation. So we have and maybe we can also we can take out this exponent 1/4. So we have 1/4 log of x, and then we have this result. So we have n log. Okay, notice that here we are dividing by the log base, so it means that this function has to be different from 0. So that means that x has to be different from 0, but actually we already said that x has to be positive and not equal to 0, so here this condition is already fulfilled. So now we can notice that this log can be split into two logarithms, given that the log base 3 of 9x can be written as log of 9 plus log of x with the same base, and we know that this is just 2. Okay, so that means that our equation here can be written as 3/2 plus 1/4 log of x, and then here we have 2 plus log base 3 of x over log base 3 of x. Okay, so why are we doing these calculations? We are doing so because here we can notice that here we have always the same term, the same equation. So now we can consider a substitution. So we can substitute this function with a new variable, let's say for example t. So we are saying that we can write 3 of x as t, as the new variable, and we know that t has to be different from 0. Okay, so that means that our equation will be of this form. And now, since t is different from 0, we can multiply the left side of the equation and the right side of the equation by t, and then maybe we can also multiply by 4 here. So if we do so, we get 6t plus t squared equal to 8 plus 8t plus 4t. Okay, so at this point you can notice that here we got basically a square equation, and to solve it we can move all the terms here on to the left side of the equation. So we get t squared plus 2t minus 8 equal to 0. Okay, and this equation has two solutions. We can notice that this can be written as t plus 4 times t minus 2 equal to 0, because here we found two numbers, 4 and minus 2, such that the product is minus 8 and the sum is 2. So at this point we get two solutions. We get t equal to minus 4 and t equal to 2. And now these are the solutions in terms of the new variable, in terms of t, but we need the solutions in terms of x, so we have to basically move back to the old variable. So that means that the first solution, let's call it t1, is minus 4, but that means that log base 3 of x is minus 4, and this means that x1, let's say, so the first solution in terms of x is 3 to the minus 4, which is 1 over 81. If we do the same with the second solution too, we will get the second solution x2, which will be such that the log base 3 of x is minus 2, but that means just 9, because it is 3 raised to the power of 2. So the two solutions are 1 over 81 and 9, which are both